All right, in this one, we're going to be continuing our talk about proving trigonometric identities. And these are our different ways of simplifying. So all these are little tricks. So if you see this and you want to try this, so I've got every single one I could possibly think of. There are extras, there's tons of tricks, but these are the most basic. So the first one is try using a conjugate. This is the most important one because for some reason we like it a lot. So if you see 1 minus cosine x over here, you want to think, okay, well, what is its conjugate? And that would be 1 plus cosine x. And you're going to multiply top and bottom by 1 cosine x. This is what you can do to any fraction. You just multiply top and bottom. That is our fraction rule. You can modify it by either multiplying or dividing top and bottom. So we then get sine x times 1 plus cosine x. And then what happens on the bottom is if you multiply this out, this is our difference of squares. So we end up with 1 minus cosine squared x, just like that. And that is our Pythagorean identity. So we already know that sine squared x is equal to 1 minus cosine squared x. So that allows us to take that denominator and replace it. So we end up with this. And so that's what you're going to be doing. And as you can see now, we're allowed to cancel the signs here. So things start to move. So if you see a 1 minus cosine x, multiply by its conjugate. So if you see that, it's the 1 times 1 is 1. And then you're going to get a positive cosine and a negative cosine. Remember, it's our difference of squares. So the middle two terms cancel. And then cosine times cosine is this. And then, so if you use the conjugate, it allows us to use the Pythagorean identity. They go hand in hand. Okay, so by doing that, we're going to turn our cosine into a cosine squared, which would then get turned into a sine squared. The next one is to try adding. So if you see a plus sign, you just add them. And so we're going to use that same idea we did just above. You're going to use the conjugate. So if you use cosine x, 1 plus cosine x, top and bottom, again, that's going to turn it in. And so I'm not going to do all this work here, even though we're supposed to. We know that this is going to turn into 1 minus cosine squared x. So that's what we have. So we know this is going to turn into 1 minus cosine squared x, which will then turn into sine squared x. We've already done the work ahead. Now, if you were doing this as a normal problem, yes, you'd want to show all your steps. These are proofs. So each step that you do has to be one at a time. You can't do like 3 steps in one because then no one can follow you. It's got to be one. And since I've already done the work up here, this is fine. And so now you would think, okay, well, common denominator is sine squared. But no, by doing that, we're allowed to now cancel these. And you get 1 minus cosine x over sine x plus 1 plus cosine x over sine x. And so by doing the conjugate, it turned it into a Pythagorean identity, which turned it into a sine squared, which simplified to give us common denominators. So it's a technique. Now that we have a common denominator, we can add the top. And obviously, we'll just continue on from here. So you can see the ones cancel, right? Or not the ones cancel, so you get 1 plus 1 is 2, and then the cosines cancel. You can continue on from there. But the whole idea is when you see this, you want to try this, okay? If you see this, you try multiplying. So we distribute, and we can already see this is a difference of squares. But if you don't see it, then you multiply. And then you can see the middle two cancel. And then we can even say, well, this is going to become it's the reverse of a conjugate of our Pythagorean identity, so we can turn it into a negative cosine squared, right? And so another one. If we multiply this, we get sine squared x plus sine x. It's just modifying. So what you're doing on each of these is when you see it, you try the conjugate. When you see this, you try adding them. When you see this and this, you multiply. And when you see this, you factor. So they both have a sine theta. So that would give us 1 plus cosine theta. So we're just modifying. That's it. As you modify, it changes the look and will help us prove our identity. All right, here's another factoring. So we've already done the difference of squares here. So now we can work in reverse. So what we have here is an a squared minus a b squared. So our sine squared theta minus cosine squared theta, what you want to do is find out what is being squared. And so that's our sine theta and our cosine theta. And then we can apply our difference of squares. So that'd be a minus b and a plus b. So this would be sine theta minus cosine theta, or sine theta plus cosine theta. And then the other one, sine theta plus cosine theta. So again, we're just modifying. So if you see this, you try this. This one is cubes. So we could also use squares here because they're both even, but I want to try a cube just to show you it. So if we have sine the 6th theta minus cosine to the 6th theta, we'll try a cube because it works. Again, it depends on the problem that you're working on, whichever one would match. So this would be sine theta, and we make our big. And so the way it is for sines, this is same, opposite, always positive. So the signs would go same, opposite, always positive. And you can see it spells soap. And then it's just our A, so sine theta, and our B, which I wrote down wrong, which is cosine theta. It probably irritated you a little bit. Cosine theta. And so then we follow along. So it's sine theta, cosine theta, and then it's sine theta times sine theta, and then it's sine theta times cosine theta, and then it's cosine theta, cosine theta. So this would be sine theta, and then sine theta, cosine theta, and then cosine theta, cosine theta. I like things that are patterns that you can actually have a rhythm to it. So it's sine theta, sine theta, sine theta, cosine, cosine. And you can even see there's 3 of them and then 3 of them. So you write 3 and you write 3 because they're cubes, so on. Lots of patterns. So we have sine squared theta, cosine theta, and cosine squared theta. So again, it's just a way to modify it. That's it. And then you also will have complex fractions like this. And so when you see a complex fraction, you want to multiply top and bottom by whatever that common denominator is. In this case, it is a cosine theta. You could also rewrite it as a division, but I'm giving you one method. That's it. And so that will cancel. Remember, this is a fraction, so whatever you do to the top, you have to do to the bottom. And that would now give us 1 plus sine x over sine x minus 1. And we can continue and see, oh, well, there's a conjugate. So then when you would go back and you would try this. See, so each thing will just appear. If you see this situation where you're dividing by one denominator, then what you want to do is try splitting them. So sine theta is being divided by sine theta. It's distributing. And then sine theta, cosine theta is being divided by sine theta. And then that again allows us to cancel. So you end up with 1 minus cosine theta, and then so on. Oh, there's a conjugate again. There's things you can do from here on out. All right. The other one is the Tripythagorean identity. So we had that up here where we took it and we saw 1 minus cosine squared theta, and so replace that with sine squared theta. You can also go in reverse. So if you see sine squared theta, you can replace it with 1 minus cosine squared theta. So we know that sine squared theta is equal to 1 minus cosine squared theta. And cosine squared theta is equal to 1 minus sine squared theta. And all of these are on that identity page I gave you. So you can just look them up. And then there it is. Now we can look up here and see, oh, well, we can do the same thing we did here. It'd be 1 over cosine minus cosine squared over theta, and you can continue. So these are just things to do. If you see this, try a conjugate. If it doesn't work, you try something else. This is to add, so we try a conjugate. If that didn't work, then you'd go back and make a common denominator and try adding them. But you know you have to add them. This is multiply. This is multiply. If you see this, we try in reverse and we factor. If you see this, try this. If you see this, try this, and so on. So each of these is just a let's try this method. Thank you.